Okay, folks, we are on the last hurrah today. We are at the end. We've only got a few topics left to talk about, really two big topics. One that we've already talked about a fair amount, so I think you're going to find it relatively easy. We've got a test next Wednesday over this first topic, and we are going to start today our forum test. So I need to be sure that you understand what I'm expecting out of you here, because this should be a very good test grade for you, provided you do the work and do it on time. All right, so when you log on to Moodle in this section under area between curves, you should see this forum here, Final Exam Prep Forum. And all it is questions I am posting, and you need to provide answers for those posts. Okay? It's not answers as in working out a math problem, taking a picture of it and putting it up there. It's actually written out answers. So if you'll look at the first question, for example, down here, what would you do if you were given a function and asked to find the equation of the line tangent to the function at x equals 3? I don't want you to say, suppose I've got the function f of x equals x squared, and then work through it, and then give me an equation. I want you to say, what would you do? What's the first thing you would do? I'd take the derivative of the function. Then after you take the derivative, what are you going to do? Plug in 3, and that's going to give you your slope. Okay, what else have you got to do in order to write the equation? You've got the slope for the equation now. What else do you need in order to write that equation? X and Y. You've got an X. How are you going to find your Y? Plug it into the original function to get your Y. So now I've got my slope, I've got my X, I've got my Y. Then I'm going to plug it into Y minus Y1 equals MX minus X1. So that's the type answer that I expect to get here, okay? Just it's something that's in all words. You shouldn't use a specific example, okay? How are these going to be graded? Well, they're going to be graded on a 4-point scale, all right? To get all 4 points, you answer it correctly, first time, on time, okay? Notice I put beside them, there should be one due every day that we have class. So there's one today, one tomorrow, one Thursday, one Friday. If you want to go ahead and answer all 4 today, that's not a problem. Just don't be late with them, okay? If you don't answer it, if you answer it on time but don't get it completely right the first time, I'm going to probably give you 2 points there, okay? But give you the opportunity. I'll respond back to you and give you the opportunity to correct. You know, so if, for example, if on that one, you didn't tell me how you were going to find the y, I'd respond back, Jordan, how are you going to figure out what the y coordinate is? And you respond back. Then you still get the opportunity to get up to the 3 points there, okay? If you just don't do it, obviously you get 0. If you do it and don't answer it right or something, you can get 2 or 3 points there. But most of the time, everybody's going to get the 3 or 4 points on that, okay? We'll probably have around 25 somewhere between 25 and 30 of these questions, because we're going to continue this until exam time there. And I have found this to be very good for students to have to write down and think through, this is what I'm doing. A lot of you know what to do mathematically, but you don't think through it all the time. So we're going to try to cover just about everything that we do with that, okay? One thing that you'll find, or should find, is that you don't see other people's answers until you put an answer up there, okay? Once you put your answer up, then you can see what other people wrote. Okay? Any questions about the expectations there, all right? Did all of you get a funny email yesterday with 40 or 30-something things listed on? What I will do is probably every weekend as I grade these, I'll update your grades, send that email to you, and you can quickly scan. I don't have a 4 on number 2. I need to go back and fix number 2. Does that make sense? So this is something that's going to take a little bit of coordination on your part to be sure things get done, but it should be a good way for you to review for the exam as well as make a good test grade. That will be a test grade. The test next Wednesday will be a test grade. The mock exam on May the 29th will be a test grade. Don't freak out on March 29th, okay? Don't freak out over that, okay? It's not going to be a killer test grade. It's going to be a test grade for you. and then we'll probably have a test over volumes right after we get back in April. This is your assignments for this week. If you haven't noticed, a couple of homeworks and 3 FRQs, and then next week we've got a web assign and a test already up there. So we need to stay on track. I promise you we're getting to the end, and you're going to do okay with it here, okay? So let's talk about 39, area between curves. I did get your test graded. I did get your test corrections in. You've already gotten your report card. All those grades should be in there. If something looks funny, let me know, and we'll correct it. Some of you have incompletes because, well, Matthew's not here, so he's got an incomplete. But okay, this first problem here should be an absolute review to you, okay? Find the area of the region bounded by the graphs of the following curves. Okay, this shouldn't be anything real new at all to you because we've done something similar to this. Actually, we've done very much this before. How do we solve this problem? Okay, we're going to integrate from 0 to 2, what? The function x cubed plus 4 dx. Okay? That's correct. That's exactly what we're going to do. Now, where did the 0 and the 2 for the limits of integration come from? The 2x values. So x equals 0 is this one down here, and x equals 2 is this one here. All right? How does the y equals 0 figure into it there? Where is y equals 0? It's the horizontal x-axis. So that kind of gives us a bottom to it. So it just says we're finding this area of this region right here from 0 to 2. And if we integrate that, we'll find an area. Integrate is something we've been doing a long time. X to the 4th over 4 plus 4x. Evaluated at 0 and 2. 16 over 4 plus 8. Is that right? Yeah. 16 over 4 plus 8, which is 4 plus 8. So we get an area of 12. Okay? Now, I want you to notice something here. This said find the area. So we're talking about something physical, the actual area under there. Would we get a negative answer? Okay. Now, we have done this before, and we've gotten a negative answer and kind of talked about it fuzzily about area. What does a negative mean in terms of area? What does that mean what does that trigger in your mind that you're thinking? Below the x-axis. Negative means at least some or most of it is below the x-axis. Okay, so now that's very good. All right, now let's look at the next question. And how is it changed? Okay, before we had y equals 0 right here. Now we've got y equals negative x. So can we color in what region we're trying to find the area of? What region are we trying to find the area of? We're trying to get above this, above the line y equals negative x, below the red curve, and to the left of the green line. This is the area that we're trying to find here. Okay? Now, we're talking about area. Should we... actually, I messed up there, didn't I? It says x equals 0, so we're not going to go past this line right here, are we? This is the area that we're talking about, right? Would you agree with me there? Now, should this number be bigger or smaller than the one on the last problem? Should our answer be bigger or smaller than 12? Why smaller? Why bigger? Why bigger? That's right. Before, with the one before, we just looked from this line up. We've added this little bitty triangle onto it here, haven't we? So the area has got to be more than it was before. Oh, I think you're right. I confused us here. That's right. It was 0 to 2 here. I messed up and drew it all in, but it was actually 0 to 2. So, yeah. So it was 0 to 2 before, so it's just from the y-axis over. It's still 0 to 2, so it's got to be a little bit more. All right? The question is how much more? Well, we know how to find the area of this here, don't we? Of the first part. How can we find the area of that bottom part? Area of the triangle. Very good. We don't have to rely on calculus even, do we? We can just find the area of that triangle there. The area of that triangle looks like it's 2 by 2 divided by 2. So it's 2. So then that would tell us that our area here is 14. Would you agree with that? Now, what if the bottom hadn't been a nice straight line like that? What if it had been a parabola? How would we have done it then? Is that what I did next, maybe, or not? Nope, not yet. So how would we do it if instead of, and y'all don't have to write this down, but what if we had this, y equals x cubed plus 4, x cubed plus 4, y equals x squared minus 2, x equals 0, x equals 2. All right? If we were to look at that graph, it's going to look something like that one did. We've got an x equals 2 and x squared minus 2. Something like this here. How would we find all of this? Well, again, we know the top part, don't we? How are we going to figure out this down here, this area? That becomes the difficult part here. That's what our goal is today, okay? And I'm going to kind of wave my hands and say, poof, here it is, okay? So it turns out that in order to do this problem, we can go back to a very, very, very simple formula. And this is the very simple formula. Top minus bottom. Okay? Top minus bottom. We're going to integrate top minus bottom. Now, that's my own, you're not going to find that in any book. I just developed that over the last few years myself. What do you think the top function is? Yeah, this function right here. So we're going to integrate top minus, what's the bottom function? Negative x dx. We're going to integrate from 0 to 2 because that's what our limits of integration are. So if we integrate that top minus that bottom, we should wind up with 14. Let's see if that happens. That's 2 up there. X to the 4th over 4 plus 4x plus x squared over 2. Evaluated at 0 and 2. Come on, Haley. Get with the program. Well, we know this becomes 16 over 4 plus 8 plus 4 over 2. 4 plus, that's 5, 16. That's 4 plus 8 plus 2, which is 14. Pretty neat. Okay? The top function minus the bottom function. Questions, comments, observations? That's just it. Poof. That's how it works, okay? So look at this problem that we have here. We've got a function, or excuse me, we've got two functions. It says find the area of the region bounded by the graphs of those two functions. I didn't give you anything else. So can anybody tell me what they think we should do here? We're going to integrate. We know we're still top minus bottom. Say that again now. Yeah, I think you said right. I wasn't. I got this. Yes, we've got to figure out these 2 points, don't we? How are we going to figure those out? Set them equal to each other. Okay? So we've got to figure out these 2 points so we're going to set these 2 equations equal to each other. Well, how are we going to solve these equations? We got to get everything on one side. X squared minus x minus 6, x minus 3, x plus 2. We get 3 and negative 2. Oh, yes, it's plus x, so that's a plus, so that's a minus, so we reverse our signs here. So it's negative 3 and positive 2. And that's what it looks like, positive 2, negative 3. So what does that tell us, Eris? The negative 3 and 2, what does that tell us? Anybody got an idea of what that tells us? That's the interval. We're going to integrate from negative 3 to positive 2 because both of these are x equals, right? So we're going to be integrating from negative 3 to positive 2. All right? Top minus bottom. What's our top function? Our top function is 6 minus x squared. How do you know that 6 minus x squared is it? We know it's a parabola. We can just look at it. Minus the bottom function, which is x, dx, and that's a solvable equation. Now, I'm going to encourage you and ask you right now to get out your calculator because it's important that you are capable of doing these problems on the calculator. You're not going to have nice, easy stuff like this on the calculator. So I want to walk you through what I would do to solve these problems on the calculator. I think it'll be very beneficial to you. Okay? On the calculator, I am going to put in both of those functions as two separate graphs. Okay? So I'm going to put 6 minus x squared. Nope. 6 minus. Boy, this thing is so. X squared on y1. And I'm going to just put x on that one there. That way, if it's something that's more complicated, I can use my calculator to help figure out which is the top and bottom. Because now when I press graph, it's going to show me that was the first one. Y1 was my first one that it was graphing. So I can look at it and say, okay, that's the top function. All right. What else can I do here? I need to find out where they intersect one another. Everybody familiar with how to find out where they intersect on your calculator? We go to second, calculate. We want to calculate the intersection. Y1, Y2, and we want to guess it's going to be somewhere over there. And we find out that 2 is one of them. If we do the same thing, we'll find out that negative 3 is the other one. You may have found negative 3 to begin with simply because you were closer to that side of it there. Okay, so we haven't done anything challenging yet. How do we integrate these? Here's where it's probably something new to you. I'm going to go back to my y equals, and we know we want to integrate top minus bottom, right? The top one is the first one, and the bottom one's the second one. Instead of retyping those functions, I'm going to hit the VARS button here and move over to Y variables and functions highlighted, and it'll have Y1 there. And I'm going to put Y1. Y1 is whatever's in this first Y1 function up here, okay? Top minus, we want to subtract that one. Variables, Y variables, function, Y2. Now, why do I do that? Couldn't I have just retyped 6 minus x squared minus x probably as fast or faster than that? Probably so. But now if I will leave y3 as that one every single time, I don't have to type it anymore. All I do is I change my two functions up here every time. And I've got exactly what I need. So what am I looking to integrate? I want to calculate the integral. Which one do I want to integrate? It's about to show you. Is y1 what I'm wanting to integrate? No, I'm wanting to integrate top minus bottom. That's not the function I'm wanting to integrate, so I'm going to press enter. I'm not. Let me start over. Second, quit. All right, so I'm going to go to second, calculate, integral. y1 is not what I'm integrating, so I want to use my down arrow. y2 is not what I want to integrate. y3 is what I'm wanting to integrate. So I'm going to move to y3. Now, what's the lower limit? -3. What's the upper limit? +2. And I get 20.833. Math, enter, enter. We press math, enter, enter. 125 over 6. That should be what I get for my answer. If we integrate that, that's what we should get for an answer there. Now, you could integrate that by hand, and you should get that as well. So it's not something that says you can't do it by hand. I just wanted to be sure you looked at the calculator to see how you could and should do it. Any questions about what we just did on the calculator, or any questions about area so far? Yes, ma'am. Okay. How do I get that on my calculator? I hit the, I go to where I want it to be at, and I hit VARS button, go over to Y variables and function, and then just press enter because Y1 is highlighted, and that'll put it in there for me. Yes, ma'am.
Mine won't let me do that. Like, it'll graph it, and then it'll say, like, it's invalid.
Let's see. Second, calculate 7. Oh, it won't graph it. Variables, Y variables. Oh, you don't. Looks like you typed in the 1. Go to variables.
Okay. It's right here?
VARS, Y variables, function, and enter.
Okay.
See, it puts a little 1 under there.
Okay.
So that's how you get those in there. Okay? You're going to have to do some of this, so be sure and keep that on your calculator. I think it'll be beneficial to you. Let's look at another problem now. Find the area of the regions between these two graphs. Now, I gave you the two graphs here. We've got a red one and a blue one here. What area are we talking about we're trying to find? Area between the red and the blue. What does that mean? What problems do you foresee with this problem? That's right. They intersect. Looks like they intersect here and here and here. So suddenly they're intersecting more. The last one just intersected twice. This one intersects 3 times. So that sounds like it should create a problem. Why do you think it should create a problem? Right. So we're really looking to find 2 different areas. We're looking to find this area, and we're looking to find this area. So we've got 2 different areas that we're trying to find. If we've got 2 different areas, what does that tell you you're probably going to have to do? Integrate twice and add the 2, okay? So if we're trying to find this first one right here, we're going to integrate. What's our top one for the first one? Is it F or is it G? F. So we're going to integrate F top minus G bottom. What are going to be our limits of integration for it? How are you going to find that? Intersection points. Based on the graph, can you tell me what the intersection points are? What are they? -2 to 0. So we're going to be integrating from here to here, F minus G. Okay? And then what else are we going to be doing? To find this other region here, region 2 over here, what are our limits of integration for it? 0 to 2. And what's the top function there? G. G minus F. Okay? And you're going to add those two things together there. Now, something you need to understand, you will never get a negative answer with these problems. Why? Right. We're talking about the physical area on a piece of paper. It has to be a positive number. So if you get a negative for either of these, know that you've messed up. Each one of them should be positive. You add them together, you should get an even bigger positive number there, okay? Is this a complicated problem to solve now, though? I mean, even integrating these by hand is not that challenging necessarily. It's something you can do. So I expect you to be able to do it. I'm not going to finish that problem out there. Any questions about it? Real simple stuff here, isn't it? Like this, okay? Sketch the region bounded by the graphs of the algebraic functions and find the area. It's not any different than what we've been doing. I just didn't give you a graph to begin with. So, what do you know what y equals x squared minus 1 is going to look like? Right, it's going to start off down here at -1 and look like that. All right, what about y equals -x plus 2? What does that look like? Linear. Crosses at 2, and it's going downstream, something like that. Okay? Now, do we need to find these 2 points here? Okay? Right, look at what else we're told here. We're told x equals 0, which is this line, and x equals 1, which is this line. So we're given an area that's being bounded. We don't need to know these points out here because we're not looking for the whole area. All we're looking for is this area right in here. All we're looking for is this area right in here. Right, 0 to 1, -x plus 2 minus x squared minus 1 dx. Exactly. Be sure you put the second one in parentheses because you've got to distribute that minus sign through there. Now, when you're doing these problems, if you do them on the calculator, you need to write down this, and then you can just put the answer on the paper if you're doing it with the calculator. Doing it by hand, you can do a little bit more there. But it is critical that you write this down. On the exam, this will probably be an FRQ. It has been for the last several years. When I'm grading this on the FRQ, you get a point for having the right integral, you get a point for having the right limits of integration, you get a point for having the right answer. So you've got to be in the habit of writing down all 3 pieces there. All right? Good. I feel like y'all are getting a very good handle on this, so I don't want to keep belaboring the points there. That next problem was the same thing. This last one is a little different, and so I want to talk about it a little bit. It says, find the accumulation function f, then evaluate f at each value of the independent variable and graphically show the area given by each value of f. Okay, lots of words to get confused on there. But let's break it down. It says find the accumulation function f. So let's focus on this part here. What does that mean do? What do you think you should do to find out what f is? Well, it tells you what f is. What does it mean to find it then, you think? That's right. Can we integrate that function the way it's written? Well, you can, but you won't get nice number answers out of it. You can integrate it, though. What's the integral of 1/2 t? It becomes 1/2 t squared over 2. If I take the derivative of that, I have the 1/2. T squared over 2 becomes t, plus integral of 1 is t, evaluated at 0 and x, right? Well, that becomes x squared over 4 plus x when I plug in x, right? Do I need to plug in the 0? What happens when I plug in the 0? I get 0, so it's not. So this is a simplified version of the accumulation function right here. F of x is x squared over 4 plus x. Evaluate f at each of the independent variables. What does that mean? Right. Is that hard to do? F of 0 is 0. F of 2 is a half plus 2 is 5/2. And f of 6 is 36/4, which is 9 plus 6 is 15. Graphically show the area given by each value of f. Graphically show the area. Graphically show the area. So what does that mean?
No, looking for a number, it's just looking for a representation or a sketch.
A sketch of it. Okay, but it says graphically show the area. What does that mean we need to sketch? What do you think that means? Did I get one of them wrong here? F of 2, 2 squared is 4, 4 divided by 4 is 1, and 1 plus 2 is 3. Okay, yeah. I'm not good with numbers. Y'all know that by now. Okay, but I want to be sure you understand. Graphically show the area given. So how do I show area? How do I show area? How have I been showing area on those other problems there? And drawing and coloring. What am I going to draw? On all of the others, if we go back and look, we drew a graph and then we colored something in. We drew a graph and colored something in. So what does the graph need to be on this problem? The graph needs to be that thing that I just circled, 1/2 t plus 1. Well, let me show you. Let me show you why I think it needs to be the 1/2 t plus 1. If I graph the 1/2 t plus 1, here's 1, up 1 over 2. This is what my line looks like. This is 1/2 t plus 1. Now, how do I graphically represent f of 0 equals 0? Well, how did we get f of 0? We plugged 0 into here. We integrated from 0 to 0. We just integrated on that line. What's the area of a line? 0, because it doesn't have any. What if we come over here to 2? If we come over to 2 and draw a line up, that's the area from integrating from 0 to 2 that we would get there. Okay? And how do I know that area is 3 there? Well, remember, this is 0, 1. This point here, if I put 2 into this thing here, Half of 2 is 1 plus 1 is 2. So this is 2, 2. If I draw, I've got a rectangle right there. The area of that rectangle is 2. The area of this triangle is 1. So I've got an area of 3 there. How would I represent an area of 15? I'd come all the way out here to 6, wherever that is. And all of this area should be 15. And I could go through the same process. I've got a rectangle of 6 down here and an area up there of 9 of that triangle. So the accumulation function, now why do we call it accumulation function, you think? What does it mean to accumulate things? To what? Add on to. We're accumulating. So if we go to f of 8, what would you expect to happen? Area is increasing because we're accumulating more area. You're going to see that word, the accumulation function, from time to time. Understand that the accumulation function simply should be something that we just keep adding to, and we just keep getting more and more area to it as we go along there. Okay, big takeaways. How do you find the area between two curves? Very simple. What's the formula? Integrate top minus bottom. You've got to remember that that's going to be important the rest of the way, okay? I'm going to stop talking. Tomorrow we're going to turn this thing around 90 degrees and we'll talk about it again.